Okay, so this is the sample calculations video that I promised you guys. There's a pretty standard format that I want you guys to have for this, and I'll be honest, there's not a whole lot of sample calculations you actually need on your first lab. Second lab will have a lot more, but this one is pretty straightforward. So your format is going to be some kind of a label telling me what it is you're calculating. Okay, then you're going to give me the base equation that you're going to use to calculate it. Solve that equation for the thing that you're looking for. Then plug numbers into this equation, and then you have the answer is, so the variable that you're looking for is equal to whatever number that is. So as an example here, I've got the percent error calculation you guys have to make, which I think this is the only calculation you guys actually have to make in the shoot the monkey experiment. You have to do a percent error of your acceleration of gravity. Now your data, you have to report 2% errors, but since it's the same calculation, in your sample calcs, you only have to show it to me once. So our heading is percent error because that's what we're looking for. This is your percent error calculation. The theoretical value minus the experimental value over the theoretical, where theoretical is a value that is given to you or it is calculated by some means, like in vector addition. We'll talk about how that works. Experimental is the data that you got from your experiment. So in this case, the slope of your velocity time graph. Times 100 to turn it into a percent is equal to the percent error. So our theoretical for this is going to be 9.8. My experimental, I just realized this is wrong, which means this is wrong. My personal experimental was 10 because that was the slope of the data that I used. And then I divide by that theoretical 9.8 again. Now, notice these bars on the side. These are absolute value bars. And if you ever ask me what the percent error calculation is, I'm going to tell you the positive difference over your theoretical. Because that's what this means. It does not matter whether you take theoretical minus experimental or experimental minus theoretical. I don't care. You can do it either way. It's not going to matter. Because you ignore any negative sign that you get from that because of these absolute value bars. Okay? Percent error is not direction dependent. It's not a vector. It's a scalar value. So it has no direction, so we ignore the negative sign. So then we plug this into our calculator, since I didn't do it properly when I was trying to do it. And so I'm going to just switch it when I plug it in. So 10 minus 9.8 equals divided by 9.8 and times 100. Okay, and that gives us 2 point, actually, it doesn't actually change anything. So it's 2.04. Since we can only have 2 sig figs, it would just stay 2.0, and that's going to be our percent error. Now, one thing missing from this example is there is no reworking of the equation, because we're looking for the thing the equation is already solved for. But if we were doing a kinematics equation, and we had to rearrange the equation before we actually plugged our numbers in, then you would also have this step here. A lot of times, this might end up being 2 or 3 steps, depending on how complicated the equation is. Especially later on in the semester, you'll start to see more of that. But that is sample calculations in a nutshell. Let me know if you have any questions or if something about this doesn't make much sense. And we can go through it on Monday if we need to. But that's it. Hope this helps.